All right, so let's see this particular question now. So over here we are given an integer array, right? And what we need to do is we need to find the majority element in this particular array, right? And if there is no majority element that exists, we can just return -1, right? And how do we define a majority element? So basically, if a given element in the input array actually occurs more than n/2 number of times, right? Then we call that particular element as the majority element, and n over here is the total size of this array, right? So we just have to find an element, if at all it exists, which appears more than n/2 number of times in this particular array, where n is the size of the entire input array, right? So that's the question. Now, for example, if you see this input sample, we are given 31332, right? So if you see 3 over here appears thrice, right? It appears 3 times, right? And if you see the total size of this particular array is 5 in total, right? So 3 is definitely greater than 5/2, because 5/2 will be 2 if we do an integer division. So that's why 3 is the majority element in this particular array, and so I have returned 3 as my output, right? And if there was no majority element, we would have returned -1, right? So that's the entire question. Now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, what we can do is we can make use of a very popular algorithm called as the Boyer-Murray majority voting algorithm, right? So let me just use this particular example to show how it works, right? What the algorithm says. So let me just give you an example. So for example, this is our input array, right? Now, to find the majority element, what we will do is, as per this particular algorithm, we will declare two variables, right? One we will call as num, right? You can call it anything, but then I'm just calling it as num. And what I will do is I will initialize it to -1 to start with, right? And also I will declare another variable, and that will be the votes variable, but for short I will just name it as the SV, right? And I will initialize it to 0, right? Now what I will do is I will traverse the entire input array one by one, right? So what I'll do is I will traverse this array, right? And what I will do, at every element I will check if my current value of num is uh, equal to the current element that I'm seeing in the array, right? So obviously, when I'm at the first position in my array, this number is not going to be equal to the current value of num variable, right? So that condition will be false, right? So if this condition is false, then what I will do is I will check another condition if my v is equal to 0, right? Now if my v is equal to 0, then what I will do is I will just reinitialize my num variable to this particular first integer or the current element that I'm seeing, and I will also increment my votes by 1, right? So now after the first iteration is done, this num variable will now be holding this first element of the array, which is 3, and the value of the vote will become 1, right? Now I will go to the next element, and again I will do the same thing. Now I will check if my num, is equal to the current element or not, right? Now of course over here it will be 3. Let me actually write it so that it will be clear, right? Like this. So after the first iteration, this num became 3 and the vote is now 1, right? Now what I'm doing is, now I'm over here at this 1, and now I will compare if my current element is equal to the current value of num or not. Now obviously clearly it is not equal, right? So then what I will check is if my vote variable is equal to 0, right? Now of course that is also not equal to 0. So then what I will do is I will just decrement the vote count by 1, right? Because see, the current element that I'm seeing in the array is not equal to the current num variable, right? And that's why I will just decrement the count of the votes, because I'm saying that, I haven't seen this particular number in the current element. So I'm just going to cancel one of its vote, right? That's how the algorithm works, right? So now what I will do is I will just decrement the vote count by 1, and now it will become 0, right? Now I will move to the next element, right? Now it is 3. Now I will again check if this current element is equal to the current value of the num or not. It is equal. So then what I will do is I will simply increment the vote count by 1, right? And now it will become 1. Now again I will go to the next element. Again I will check if the current element is equal to current value of num or not. Now obviously it is equal. So again, I will just increment the count of the vote by 1 and it will become 2 now, right? Then I will move to the next element. Again, I will check whether num is equal to the current element or not. It is not equal, right? Then I will check if my v is equal to 0. It is not equal to 0. So now I will simply decrement the vote count by 1, right? Because one of the votes for the current value of the num got cancelled because I saw some other element, right? That's how we have to do it, right? And now since I've traversed the entire array, I have, I'm sitting at the last index of the array. Now what I will do is I will simply check if now after the entire traversal of this array, is my vote count greater than 0 or not, right? Now if it is greater than 0, then what the algorithm says is that whatever is the current value of the num variable, that might be the majority element of this particular input array, right? If at the end of the entire traversal of this array, if the vote count for this num variable is greater than 0 actually, right? So then what we can do is we can simply take this particular number and just check the count of this particular number in this particular array by doing another traversal of this entire array in linear time, of course. And then if that count comes out to be greater than n by 2, which is the size by 2 of this particular array, if it comes greater than that, then we can declare it as the majority element and we can just output it, right? And if it is not greater than n by 2, if it is less than or equal to n by 2, then we can say that there is no majority element in this particular array and we will just return -1, right? Because this particular algorithm says that if at all there is a majority element, it is going to be the one which got greater than 0 votes at the end of the entire traversal, right? So that's the algorithm. And if my vote count is, of course, equal to 0 at the end of the entire traversal of this particular array, then also I can conclude that there is no majority element in this particular array, and I can again return -1, right? So that's the entire algorithm. I hope you understood it. Now also let me just extend this particular example a bit. Now for example, I also had a couple of more numbers over here. For example, I had 1 over here. Let me just expand this, right? I had 1 over here and I had another 1 over here and I had a 0 over here and then I had a 1 over here, right? Something like this, right? So now till here we got this, right? My num is still 3 and the vote count is 1, right? Now I will go to the next number. Again, I will check if the num is equal to current element or not. It is not. So now I will just decrement the value of the vote count by 1. So now it will become 0, right? Now I will again go to the next element. Again, I will check whether num is equal to current element. It is not. So now what I will check is that if my v is equal to 0 or not, right? And now my v is equal to 0. So now what I will do is I will just reinitialize this num variable to the current element, right? Now I am changing my value of the num, right? Because the vote count of the current value of the num became less than 0 essentially, right? So it got entirely cancelled out, right? So now I will just reinitialize my num to the current element, which is 1, and also I will increment my vote count by 1, right? And that's exactly what we did in the first iteration also when we got the first element, right? Because initially our num value was -1, vote count was 0, and since 3 will never be equal to -1, and the vote count is obviously equal to 0 in the beginning, so we just reinitialize the num value to the first element, right? And that's what happened over here as well when the vote count became less than 0 for the last num value, right? So that's what we have to keep doing, right? Now when I go to the next element, again, these two numbers won't be equal. So I will, and then I will check if v is equal to 0. Now v is not equal to 0. So I will just decrement the vote count by 1 and now it will become 0, right? And now when I go back to the, again to the next element, this will be 1 and now the num value and the current value of the element will be equal, right? So now I will just check, I will just increment the vote count by 1 and it will become 1 now, right? And now I have reached the end of the entire array, so I can stop here. And now what I have to do, I have to check whether my vote count is greater than 0 or not, right? Now it is greater than 0, right? So now as per the algorithm, whatever is the current value of the num variable, that might be, possibly be the majority element, right? So now I will check the count of this particular num value in this particular array. And if that count is greater than n by 2, I can declare it as the majority element. But if you see over here, clearly it is, not greater than n by 2. We just have 4 ones over here, and the size of the array has now become 9, right? So 9 by 2 will be 4. So, I mean, to become a majority element, this should have got 5 occurrences, which would have made it, greater than n by 2. But since I just have 4 ones over here, so it is only equal to n by 2. And so it is not the majority element, right? And so my output will be -1 now in this particular example, right? So I just wanted to explain you the other case also, if there is no majority element like this, and still we can get vote count greater than 0 at the end of the entire traversal, right? So this is the entire algorithm for you. And also talking about the time and the space complexity. Now, clearly we are not using any extra space over here, just apart from these two variables, which will be constant, right? So the order of the space complexity is order of 1, right? And talking about the time complexity, again, we are just traversing the entire array linearly, and we are traversing it twice, right? So which is fine, but still it is going to be order of n, right? It will be linear time. So the time complexity is going to be order of n, and the space complexity is going to be order of 1, right? So that's the entire algorithm. Now let's jump to the IDE and code this particular solution. All right, so now let's implement the solution that we discussed, right? So first of all, let me just declare a function, and I will call it as the majority element, like this. It will accept an array. And now, first of all, I will just capture the length of this particular array in variable n, right? Like this. And then what I will do is I will declare my num variable and initialize it to -1, and also declare my v variable, which is for votes, and initialize it to 0, right? Now I will run a for loop to traverse the entire array, right? Like this. And now what I will do is I will keep checking if my current element, right, is equal to num or not, right? If it is equal to num, then what I will do is I will simply increment my vote count by 1, right? If it is not equal to num, then I will check if the vote count is equal to 0 currently, right? If it is equal to 0, then I will just reinitialize my num variable to the current element, right? Like this. And also I will just increment my vote count by 1, like this, right? And if it is not equal to 0, the vote count is not equal to 0, and also the current element is not equal to num, then what I will do is I will simply decrement the vote count of the current element by 1, because one of the vote got cancelled, right? So that's what we are doing over here. And I will just keep doing it for all the elements of the array, and once I'm done traversing the entire array, I will come out of this for loop. And then what I will check is if my value of the votes are greater than 0, right? So if the vote count is if the vote count is equal to 0, right, not greater than 0, I will just return -1 over here, right? And if it is not equal to 0, that means the vote count is greater than 0. Then what I will do is I will just declare a variable over here, count, right? Because now I have to check whatever number I finally got in my num variable for which the vote count is greater than 0. Is that really a majority element or not? And so I will just check the count of that particular number in this particular array, in the input array, and see if that count is greater than n by 2 or not, right? So that's why I'm just declaring another variable count, initializing it to 0. And now what I will do is I will again traverse this entire array like this, right? And I will just keep checking if my current element is equal to num or not. If it is equal to 1, I will simply increment my count variable by 1, right? So that's what I'm doing. And then finally, after traversing the entire array, if my final value of the count is greater than n by 2, right, and I will use an integer division over here, then I simply need to return num, right? Because num is then going to be my majority element. And if this condition doesn't come out to be true, then what I need to do is I just need to return -1, right? So that's the entire algorithm from top to down, right? Now maybe what we can do is we can just test this particular algorithm once on a sample test case that we also saw while explaining this particular problem. So I will call the majority element and I will pass an array, the same array that we saw, 3, 1, 3, 3, 3, and 2, right? Now if I run this, I should get the majority element as 3. So my output should be 3. Let me run it. So if you see over here, my output is 3. I got 3. Let me run it again. So if you see, I got the output as 3. So this gives me the correct output. My majority element is 3 from this particular array, right? So this is the entire solution. I hope you understood it well. And this is the implementation of the Boyer-Murray majority voting algorithm, right? So now I will see you in the next video. Thank you.